The world of Ethernet is ever evolving, no matter whether we're connecting workstations, wireless access points, or gigantic HPC clusters. But what does it look like, and how will it shape the future of emerging technologies? In this episode of the On-Premise IT podcast, we debate whether or not the future of AI needs Ethernet. Welcome to the On-Premise IT podcast, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth, and as a part of Gestalt IT, I get to record these great episodes and bring you the perspectives of a group of IT experts in their field on a variety of enterprise IT topics. I'd like to take a moment for our guests to introduce themselves before we jump into the premise or the topic for today's episode, starting with Drew.
Hey, I'm Drew Conry-Murray. I am a co-host at Packet Pushers. I've been writing and podcasting about networking and IT for a long time.
Jordan Martin, I'm a principal architect at Worldwide Technology, focusing on edge to cloud networking. Been doing that for about 25 years now.
Awesome. And joining us today, our special guest, I'll have him introduce himself. Jay, go ahead.
Hi, my name is J Metz. I am a technical director for AMD, but I'm here today to talk more about Ultra Ethernet as the chair of Ultra Ethernet. And just in case we happen to talk storage, I'm also, just for sake of disclosure, the chair of SNIA as well.
Well, thank you very much for joining us. Let's jump into the topic for today's episode. You may recall a few weeks ago, we recorded an episode and said that AI wasn't going to be displacing InfiniBand anytime soon. Well, the head of the Ultra Ethernet Alliance reached out to me and said, I'd like to talk to you about this. And after our conversation, I said, I'd like for you to talk to some other folks about this because I think that your perspective on it is very fascinating, obviously coming from a place where you're very much more familiar with what's going on. So guess what, folks? The premise for this episode is that the future of AI does need Ethernet. So I'm actually going to start off by asking Jay, our friend from the Ultra Ethernet Alliance and said DMer on Twitter, can you maybe tell us a little bit about where the idea to displace InfiniBand with Ethernet kind of came from and what those drivers are right now?
Well, I think that's an excellent question because it's actually the wrong one. So the idea was not to necessarily displace InfiniBand. InfiniBand is a phenomenal technology. It has been used as the gold standard for technologies that need high performance networking for a long time. There's a lot of things that InfiniBand does right, and I don't think anybody in their right mind would say that InfiniBand is not the right choice for, the kind of workloads we're talking about. The question really had to do more with an age-old question that we've been asking for a couple decades now, which is, how do we capitalize on the ecosystem, the cottage industry, the experience, the demographics, the actual foundation that we have with Ethernet that, has a very strong and powerful roadmap, not just in terms of speeds, but also in terms of flexibility, right? So we've asked ourselves this question before over many years for a variety of different workloads, and this is just one of the same ones that we're looking to do. Over the last several years, we've seen, a number of the top 10 high-performance computing solutions be Ethernet based, right? So it's not as if this is a wild-eyed, crazy idea to take a technology that already has a track record in these kinds of performances and these kinds of workloads to make it even better.
Okay, I can see that. But if you're not looking to displace what's already there, is there a different reason other than, we've just been using Ethernet for a while? Because as the founder of TechField and Gestalt IT, Stephen Foskett, is fond of quoting Bob Metcalf from 3Com. I don't know what the future of networking is going to look like, but we're going to call it Ethernet. What we're dealing with today is radically different than 10 megabit Ethernet.
Oh, sure. But then again, that's the whole point of it, right? I mean, you take a general purpose network and you call it Ethernet, regardless of which side of the coin you're facing, right? Or you're flipping, right? Are we talking Ethernet in terms of the sheer speeds and feeds? Are we talking Ethernet at, the capabilities at the link layer? Are we doing it at the routing layer? Are we doing it at the transport layer? Which part of it is Ethernet, right? And you could change one thing or you could change all of it and it still winds up being Ethernet. So I don't think Bob was wrong about that whole thing. I use his name as if we're best friends. I've never met the man. But I mean, ultimately at the end of the day, the flexibility gives us a great deal of opportunity to tweak what we need to tweak. But it does require a different way of thinking, right? So when we think of Ethernet, we tend to think in terms of horizontal layers: physical layer, link layer, transport, addressing the whole stack that we're all familiar with, that we know and love and hate. What we don't typically think of when we think of Ethernet is the vertical alignment that's necessary, right? Because everything is encapsulated, and you've got if you look at the frames, they're all encapsulated into these kinds of environments that you've got, your error checks at the end, and you got your headers at the beginning, and you just sort of bundle it up like a Mariska doll. The problem is that when you start to talk about, the vertical alignment, right? But what are the consequences of having a change in the link layer that affects up all the way into the transport layer or the software layer above? How do these things kind of align to make sure that you're having the most efficient kind of a process? Well, that's both the pluses and the minuses, right? You can handle a lot of these kinds of changes, but what you tend to find out is that people will just add in abstraction layer and abstraction layer and abstraction layer until finally you're just dealing with so many different abstraction layers that all the benefits you've got underneath are just washed out by the sheer amount of virtualization you've got at the top of the stack. Where InfiniBand does things really well is that it's a very tightly coupled network that has a good understanding of what the endpoints are doing and what the actual fabric is doing, and that is a strong proponent for workload specific types of solutions. Well, that's great. So why can't we do that? Well, the answer is we can. Right. So what we're looking to do in Ultra Ethernet is an incredibly ambitious project, again, all the way from the physical layer and up, but we're also creating these horizontal approaches to being able to handle what you do in the link layer affects what goes on in the transport layer, what goes on in the APIs. And that is true for management. It's true for storage. It's true for compliance. It's true for performance. And we're building all that in, security, of course, we're building that in all from day one. And so what we're looking to do is say, look, this isn't just a hodgepodge of different horizontal layers that we're hoping that will align up. We're actually making a concerted effort to allow that to happen.
I want to give Drew and Jordan a chance to jump in here because, you guys have talked to a lot of people out in the real world who are kind of evaluating these solutions, whether they are, focused on just purely deploying AI or, they're investigating the other opportunities that can be afforded by enhancing Ethernet like this. So, do you see a different perspective than what we've talked about so far?
I guess one question that I have for Jay as a representative of the Ultra Ethernet Consortium is, InfiniBand works for AI. So is Ethernet just sitting on the sidelines and thinking we don't want to miss out on this market opportunity, so we better do something? Is that a driver there?
No. The real issue is that it dives down into how InfiniBand solves the problem versus how Ethernet solves the problem, right? And what the problem actually is. So one of the problems that we are trying to solve is what happens with massive scale, right? So right now you've got limitations of the kind of number of actual endpoints that you can have in any kind of system, whether it be Ethernet or InfiniBand. But we want to go many times multiples of doing that, like almost an order of magnitude larger, right? Million endpoints, for instance. The problem that you have with an InfiniBand metaphor, the paradigm that you're talking about, is that you effectively have a limitation on the efficiency of the network that you're using because of the nature of the one-to-one relationship between endpoints. And that has a number of knock-on consequences that go on, including things like increasing of tail latency because of the pattern of the behavior of the traffic that goes through. What we would like to do is we want to be able to use all of the available links that we've got. Well, that creates problems, right? Those problems include congestion, which includes congestion signaling, congestion notification, congestion mitigation. It includes proper semantics at the approach if you want to have kind of this packet spraying from all to all approaches that is far more granular. There's a number of different problems that have to be resolved that you can't do in the current paradigms, and that's true for both Ethernet and InfiniBand. Now, without changes, right? That's not to say that the changes can't be made. So the problems that we're trying to say is that, look, you've got these two different profiles. You've got an AI profile and you got an InfiniBand. I'm sorry, you got an HPC profile, right? AI and HPC. InfiniBand's useful for both of them, but you kind of have to tweak to marry the one for the other. The other problem you've got is you've got cloud providers, you've got the big, large, mega data centers, and then you've got the regular enterprise and clustering approach. So Ultra Ethernet is saying, look, if we're going to do this, we have to be able to handle order delivery on an order delivery, reliable, unreliable. And you've got these kind of mixing and matching that you have to do. And where do you do that inside of the Ethernet transport or inside of the Ethernet layers? And it happens that we're approaching it mostly inside of the transport layer. We're also tightly coupling it with the software APIs to be able to handle the above APIs that go into the software to go along with it. And so what you're going to be able to do is saying, well, what is my workload traffic going to be? Is it going to be HPC or is it going to be AI? Is it going to be really large scale or is it going to be small rack scale, row scale type of environments? How do you tweak the appropriate semantic layer and the packet delivery service to be able to address those different types of workloads? And how are you going to be able to tweak that so that the actual workload itself is conducive to the best possible performance for the type of behavior on the network that you're looking for? Is this going to be done inside of the switches or is it going to be done inside of the endpoints? All of this flexibility has to be done very carefully, and that's what we're looking to do inside of the Ultra Ethernet Consortium. So it's not just a simple matter of saying, this is what InfiniBand can do or InfiniBand can't do. We're not, believe it or not, we're not actually looking at InfiniBand in each of these conversations. We're looking at the problem we're trying to solve and how Ethernet can solve that particular problem and what has to be changed or modified or adapted to make that happen without necessarily going back and throwing the whole baby out with the bathwater, right? So the purpose here is that, look, with Ultra Ethernet, we're trying to say, how do we go backwards compatibility? How do we go forwards compatible? And at some point in time, that transition is going to happen. In all of these different environments, we're expecting a certain amount of brownfield environments, but in HPC, for example, and in AI, you find yourself in more greenfield type environments, as a result. And that means that we have an opportunity, especially now, to make adjustments and make changes that are going to be future-proofing for the heavy use of DPUs, the heavy use of endpoint, understanding and relationships, the intelligence inside of the switching network when necessary to handle that in-network compute component, right? So, but you don't need it all. You don't need all of it. It's not an all or nothing deal. And as we start to go through with really highly tightly coupled AI GPU clusters, for example, which is on our projected roadmap, it's there for when we need to go ahead and do it. It's just not there. It's just a player to be named later, but we have it as part of our mission in our charter.
So Jay, you kind of mentioned that we're talking about not displacing InfiniBand as much as we're talking about giving Ethernet better performance profiles and things like that. But I think it might be a good idea to kind of recap something you and I had discussed as to which Ethernet network we're replacing, because unfortunately, Ethernet has become ubiquitous when it comes to the terminology that we refer to when we're building a network. It could very easily be the interconnects between servers. It could be the WAN interconnections. It could be how my client device connects to the network. Which network are we going to be upgrading, if you will?
And thank you for reminding me, because that's probably what I should have started off with. I should have led off with. So we identify three basic network types that we recognize. The one is the general LAN, WAN, Ethernet that we're all know and love with internet and that kind of stuff. And Ultra Ethernet is not concerned with that at all, right? So we don't really care, or care is the wrong word. We don't focus at all on the normal north, south, east, west traffic that you're used to inside of data centers or enterprises or even small, businesses, or your Wi-Fi connectivity into the ethosphere, right? All of that is considered to be, outside the scope of what we're looking to do. We are looking for a workload specific type of approach to handling two specific kinds of networks. And we call them, creatively enough, network number one and network number two. Do not ask engineers for marketing advice. Let me tell you this. Okay.
I wish more engineers did marketing, frankly.
Well, I'm not sure I could agree with that completely, but I do see the argument there. Nevertheless, so the network number two is what we're talking about in terms of scale out networks, right? Scale out networks primarily for that million node cluster for HPC and AI. Will you have an AI cluster at million nodes? I don't know. But some of our members tend to think that is not just a possibility, but an inevitability, right? And obviously, if you're talking about a million nodes, you're talking really large systems, right? So you can probably guess who's more interested in that particular type of solution. The network number 3 is the one that I was just talking about. It's a scale up GPU, really accelerator network. It doesn't have to be a GPU. It could be an accelerator, any kind of accelerator network that tends to be much more tightly coupled and very high speed, very high bandwidth, very low latency. A lot less probably concerns for tail latency than the really large systems, right? But they overlap. They're not mutually exclusive by any stretch of the imagination. So we're really kind of focusing on that middle network right now for large scale out systems that are going to need the most amount of immediate work. That'll also be applicable once we move into that so-called network 3 accelerator focused network of scale up.
And who do you see wanting to build Ethernet-based, I guess, fabrics for AI? Is it the cloud folks? Is it big enterprises?
Well, I mean, we have the list on our website of all the people who want to have their logos shown, and it's quite a lot. You got the regular players that you'd expect, right? We've got Microsoft, we got Oracle, we've got a few Chinese hyperscalers, there's no shortage of providers that are looking to solve that particular problem in their own specific networks. We've also got on the steering committee, we've got HPE, you have Cisco, Arista, and I always hate to name names because I always forget important people, right? But you also have the providers of you've got Intel and AMD, of course, are also on the steering committee. But we've gone from having effectively 6 companies to almost 60 companies in less than a year, right? Actually, more specifically, we've gone from 10 companies to 60 companies in less than 4 months, right? So there's a lot of companies that are looking to try to solve this particular problem, and they range everything you can imagine. They go from the physical layer all the way up to software vendors to compliance and tests to performance. Everybody has a belief that this is going to be something that is worth investing in, and so we're very careful about making sure that we don't burn too bright too fast by doing things the right way. So these really large systems, I think that you'll find the people who want to deploy them, the government agencies, the international government agencies, they're interested in participating. Of course, the hyperscale cloud providers, they're all participating. But whether or not they actually participate in UEC or not, I think we've actually seen some evidence, independently of the non-UEC members who are indicating that they want to do this as well, right? So it's a problem that they're trying to solve. It's a problem that we're trying to solve. It's just a matter of how you approach the problem.
So my reading of the market is NVIDIA is essentially controlling InfiniBand. NVIDIA is selling you GPUs, and NVIDIA is selling you lots of SDKs and so on to build these AI workloads. Is part of the emphasis by the industry as a whole to say we don't want NVIDIA to own everything, so let's make Ethernet a valuable option as opposed to InfiniBand?
I don't think that's a correct way of looking at it. I mean, for one thing, we're an open organization. If NVIDIA wants to come and join, they're more than welcome to come and join. There's absolutely nothing that to stop them from joining. This is an NVIDIA decision. NVIDIA's approach to solving the problem with their Ethernet solutions, again, it's an NVIDIA solution, and they wish to do it in that particular fashion. So I can't stress this enough. I mean, we have open doors for everybody who has a vested interest in developing the technology. NVIDIA has not yet, as of now, shown interest in doing so. That's perfectly up to them. But the welcome mat is open for them. We don't really think about their solutions at all as we start to approach the issue, right? And so they have their approach, and it seems to be working out really well for them. I've seen their market cap, and I don't have any what's the word I'm looking for? I don't have any advice for anybody who is looking to, to handle the NVIDIA approach versus our approach. I just know that they're completely separate. And, our approach is open. We're going with an open solution. We're looking to a broad ecosystem and industry method of approaching the problem. And we tend to think that that's the best way to solve what we think are the problems that we're going to be facing.
So one question that has come up kind of along these same lines of the approach to take, you mentioned earlier that you're trying to solve a lot of these problems in Ethernet itself by adding telemetry and figuring out how to do packet spraying and things like that. But I think some other companies are kind of taking the approach of, well, I'll solve this in the NIC or in the DPU or in the host somehow, and maybe not necessarily in the network or the switch itself. Is UEC taking an agnostic approach to this, going, well, we just want to solve the problem? Or is there a preference to solve it in the network so that people who attach to this Ultra Ethernet are not having to do a lot of extra heavy lifting or buy a lot of extra equipment to interface with it?
Well, so that's why it's really kind of critical to start asking yourself, what exactly is the Ethernet we're talking about here, and at what role and what function in the block diagram are we talking about? I think one of the things that DPUs have brought to the table that kind of opens up the possibility is that now all of a sudden the network trust boundary is no longer inside of the switch, right? So as we start to talk about the functionality of the network stack, things that would otherwise have been inside the switch could be pushed down into the DPU. Same thing with the host. Things that could have been in the host can now be pushed out to the DPU. So the real question has to do with what are the relationships between the CPUs, the GPUs, meaning the accelerators, the DPUs inside of a host. But now let's ask ourselves an even broader question. What if it's not in a host? What if the DPU is the host? What if we're now talking about rethinking about the nature of the roles in the network stack and the trust boundaries? And I say trust boundaries, I'm talking about where the network begins and the host ends, and where the switching begins and where the NIC ends or the DPU ends. Where are these decisions actually being made, and can we separate those out into finer granularity? If you can do that, then all of a sudden now what you're looking to do, because ultimately all of that stuff has to do with how do you handle the transference of memory, right? How do you move data from one memory location to another memory location? Now we're basically blowing it up like a Hoberman sphere and putting it back together and saying, oh, maybe I don't have to have this particular memory location here. Maybe I can put it here, and maybe I can attach an endpoint to the fabric at that point. So now what we're doing is we're expanding and exploding the possibilities of what constitutes an endpoint, and it doesn't necessarily have to be inside of a switch, doesn't necessarily have to be inside of a DPU. It could very well be inside of an accelerator. All we have to do is say, can this role be placed in a completely different function than what we've traditionally looked at in order to make it more efficient? Now, for example, let's say for instance, I happen to have a PCB, right? I happen to have a motherboard, and that motherboard contains a lot of extra intelligence on where the memory is going to be located, how the memory is going to be accessed, how it's going to be moved, and how it's going to be represented across a network. Well, what happens if that memory happens to be on the network as opposed to going through multiple different devices, right? All of these kinds of implications are now being made possible by saying, I have different means of being able to approach this by calling them, for what they are. And I can put them in different locations where they're the most efficient, right? And I can separate that out, and I can have a different latency budget based upon whichever kind of functionality I'm looking to do. These are all the kinds of things that AI is bringing to the table as a mechanical and processing functionality that your network has to be aware of. Well, what does that mean? Now my storage and my memory are going to be necessarily colliding at the same time. So that's why we have a storage work group inside of Ultra Ethernet. Now the storage role and the memory role are going to be colliding, and they're going to have a different interface with the network. What does that look like? This is why we're trying to say that, all bets are off when you start to think about what actually constitutes a memory endpoint and where it's going to be. At the same time, you've got switches that could handle certain types of acceleration and efficiency in the network to take the burden off of the endpoints, to be able to handle really large systems where congestion is going to be an issue. Building off, congestion mitigation, congestion signaling, congestion awareness, congestion trimming, all of those things are also a possibility for those who say, this is the kind of metaphor and paradigm I want to use inside of my network. Well, great. let's do that. Let's identify what you can do and make the endpoints aware of what you're looking to accomplish based upon the profile that you're looking to run without necessarily requiring it. So your profiles aren't going to be mandatory, but within profiles you will probably see some requirements that in order for this to work, you want to have requirements in order to have the profile work, but the profile itself won't necessarily be mandatory. So this is the kind of graduated mixing and matching of the kind of approach you're looking to take, and still yet wind up with a functional interoperability that's going to say, look, if I'm going to be doing this profile, I want people to know that I'm going to be doing this, and I want them to be aware of that. So they're going to have to do X, Y, and Z, right? So, or for those who are outside of the States, X, Y, and Z. So we need to make sure that, whatever it is that we do, we are aligned both in terms of the paradigm as well as in terms of the possibilities. And yes, it's taking quite a bit of care to do that. But that's the magic of how Ethernet gets used inside of such an environment.
So I'm thinking about Ethernet from maybe a more traditional approach. The networks that you said that we're going to kind of aren't necessarily relevant for where these things go. But when we talk about design and architecture when it comes to networking, one of the things that we do, we talk about failure domains a lot. We talk about how do we isolate systems and how do we bring things about. So what I do know about InfiniBand, right? Very, very large, very, very high performance L2 network that's non-routed, right? So we have an Ethernet capable of being routed. What does that dynamic look like in these specific networks? Like, is there some advantage using Ethernet that gives you an ability to provide better, failure domains? Because if we're talking, a million node network, that's going to scare the hell out of any network architect, administrator, engineer, to put it all in an L2 domain, right? So what does that look like between InfiniBand and what you're talking about from an Ethernet perspective to help us understand, like, are there some advantages in this space that might be for some resiliency and failure domains?
So the failure domain gets lifted up out of the L2 into the L4 for the most part, right? And I'm using a really broad stroke here, right? There's people inside of UEC who probably want to kill me for saying that, but just for the sake of keeping it nice and clean, a million node layer 2 domain would scare the living crap out of anybody who's got two brain cells to rub together, right? Hell, 100,000 node domain would probably do the same thing. So what's happening is that we're doing an awful lot of effort inside of the transport layer to be able to handle the proper semantics and packet delivery services, which are going to be communicated and negotiated amongst all those different end nodes, right? And so I have to be careful about what I can go to, because we haven't ratified the proposals yet. So I'm a little bit limited in how far detail we can get into. But generally speaking, we're creating a tight integration with libfabrics above the transport layer to be able to handle an awful lot of the negotiation at the software level. But the transport layer itself is going to be able to identify and self-identify different semantics and different semantic behaviors based upon the size of the network as well as the type of workload that's going to be handled. So a lot of what it is going to be done is that the transport layer is going to be a heavy lifter for much of the issues that you just discussed, right? Now, most of the people who are generating and administrating the network one networks will never have to deal with this because of the fact that they've got a different problem to solve. They've got the generic Ethernet problem that multiple different workload types, multiple different tenants, multiple different types of I/O blending that you have to deal with, especially when you're talking about virtualization and containers and those kinds of things. The kind of problem that we're solving is really having one basically one type of workload, maybe with multi-tenants in that one type of workload, but they're all going to be following the same network characteristic, right? So where things are going to be handled is we're anticipating, at least, the singular workload type is going to be the mitigating factor as to whether or not you would use a network one solution with all the different kinds of well understood and well generated solutions that have already been put in place, or an Ultra Ethernet solution, which is going to be very workload specific and data transfer specific for those types of profiles. And I think by and large, you're going to find that as we start to move into that, I mean, those admins are going to want to learn more about Ultra Ethernet. We're going to provide the education necessary for getting them involved in that when it's appropriate. I think part of what we need to do is, it's a crawl, walk, run to a certain degree. We're kind of in the walk stage. We kind of blitz through the crawl stage of it. But before we get into the running stages, there's an awful lot of things that people have to get out of their idea of way of doing things. Because Ultra Ethernet does have certain HPC characteristics that not a lot of general networking people have, right? They don't necessarily have a lot of HPC under their belts, right? So we're going to have to get them to think like an HPC person, even if they're doing AI in some ways, because a lot of the work that we've been doing is, very familiar with those who are doing high performance computing networks, but not necessarily, immediately transferable to the general Ethernet admin, right? So there's an education thing that we're going to have to do, and one of the things that we're taking into account is when we do the compliance testing, when we do the performance, when we do all of these kinds of characteristic of the workloads and so on, we're also keeping in mind how do we educate people about how to use this properly and whether or not it's even the right way to go about doing it, right? Because generally speaking, I've had questions that have dealt everything from how do I do this in Wi-Fi to how do I do this for blockchain? How do I do this for a lot of different types of things that may not actually necessarily be the most appropriate way for using this type of technology. And so that's one of the things that I'm learning, that we're going to have to do some education along the way to say this could be or won't be, what you're looking to solve. Because quite frankly, what's new may not necessarily be the best thing if you're not trying to solve this particular problem.
Right. There definitely seems to be a tie into scalability, like just an immense level of scalability when you talk about where this is going to be deployed. And there's a study, not even talking about million node, talking about a couple thousand node that Facebook did between Ethernet and InfiniBand, and it was like up to 2,000 GPUs, like just traditional. I think what you're calling, network one networking was, with some enhancements, was more than enough, and it kind of just kept on pace. And then so once you got beyond that, you started talking about specialized. So I do wonder, like, I wonder about the pervasiveness of this. You mentioned some of the people who are engaged with your project, being the cloud scale, web scale type network providers, and of course that makes a lot of sense. Obviously, anyone who's providing AI as something part of their product line. I just wonder, how far does this come down into the enterprise market, or is this a very so niche, right, and so specialized into these people who are going to provide AI services to people, things that, think of it like cloud, right? There's so many things that happen in networking around cloud that the typical practitioner doesn't have to concern themselves with, because the typical enterprise doesn't have that level of scale. So I'm just kind of curious, what's your view on where the practicality is of this technology? Like, who's going to be using it? Because I imagine there's got to be a lower bound, right? Like, it's not going to be everywhere.
Well, so think of it this way. Let me just give you a casual metaphor, and don't take this to the bank, okay? Just for the sake of argument. Let's just suppose, for the sake of argument, that you want to take a common storage metaphor, right? Where you've got a front end network back to the clients, and you've got a back end network between the controllers and the actual storage devices, right? There's nothing that says you can't use an Ultra Ethernet based solution to have the back end network for the controllers to be able to communicate with those storage devices. For instance, throw in some DPUs, and now all of a sudden you've got a very intelligent network for essentially what would be an AI-based cluster, just using data storage as the transport mechanism. There's really no broad stroke difference between those types of environments, right? At the same time, you could put in, UEC aware NICs inside of the hosts and be able to capitalize on that kind of traffic if you wanted to do. I'm like I said, don't take this to the bank. I'm just talking about what ifs and what you could possibly do. The point I'm trying to make is that it's not necessarily an all or nothing, right? The whole ability to mix and match what you need, when you need it, where you need it, is going to be one of the metaphors that you can basically approach, depending upon the type of the system that you want to do. Where the danger is if you try to do mixing and matching outside of that trust boundary, right? If you're trying to say, oh, I like the security model that UEC has, and we're going to try and implement that in our network one, and then it doesn't get you the kind of performance you're looking for, well, that may be because of the fact that there are other issues inside of network one that you weren't taking into account, and that we weren't taking into account, because that's not our goal, right? You might find yourself in an environment where you've got these arbitrary clusters of AI related, modeling, right? So for example, let's just say for the sake of argument, you want to have a deep learning modeling approach, but you need to take the data structure out of the data and you need to convert it into something else so that you can actually process it inside of your CPUs, right? That is a common problem inside of deep learning. You've got multiple data movements that you want to handle. And now all of a sudden you've got this extra layer in between because you've got the modeling of the data structure that has to be modified before you can get there. Okay, what's the solution? Well, you put in computational storage solutions in there. Are they UEC aware? Are they not UEC aware? Well, now you're putting you're inserting a model of data communication between the end nodes that may or may not wind up being, taken advantage of UEC, even though your overall metaphor is like, well, I got UEC between these different things. Is it going to help me out? Well, you just inserted something in between, right? So if you created a data structure model of how it needs to be moved from one location to another, the network itself isn't going to help if you've got this buffering stage along the way. So your overall architecture makes a huge difference based upon what you're trying to accomplish. And anybody who comes in and says that UEC or InfiniBand or traditional Ethernet is a panacea for all the workload problems that you're facing in your data center is either trying to lie to you or sell you something. And I'm trying to do neither.
But it sounds like you're saying even if you are an engineer who isn't necessarily building out an AI-specific fabric, there could be developments or enhancements that come out of UEC that you could find a use case for in your network.
I believe that we are. We've got a crap ton of different vendors who you would not normally perceive to be AI or HPC oriented, and they're all part of UEC to solve this particular problem, right? So they see something in there. I think one of the things that's, kind of interesting is that that's a good thing, because that means that people aren't trying to simply say, well, this is the way we've always done it. This is the way we've always done storage. This is the way we've always done memory. This is the way we've always done management of networks. They're looking at possibly say, well, can we do this in my existing environment and make it better? That's good. That's a good thing, right? And I do think it won't happen today, won't happen tomorrow, probably won't happen by the end of this year. But if we're trying to incorporate those things into traditional networks, well, eventually that's going to wind up getting in there. I think it's going to eventually be, a really strong candidate for the next great, VC venture. Who knows?
Well, this has been a very fascinating discussion. And as you can tell, there's a lot of questions around how Ethernet is going to be able to make that leap to be more performant for the things that we need it to do, as far as HPC and AI and a lot of other things. And if you want to keep up with all of the advancements that are being done and all of the standards that are being released, Jay, where can people go to find that information?
Well, fortunately, it's pretty easy. You can go to the website at ultraethernet.org, where there is a very clearly written white paper to describe all the stuff that we're currently doing. We are also available on Twitter, /X at Ultra Ethernet, and LinkedIn also. We post updates on Ultra Ethernet LinkedIn as well.
All right. Well, thank you very much for this fascinating discussion. And I want to thank our guests for joining us as well. We will be back with another great episode of the On-Premise IT podcast in just a couple of weeks. Until then, if you want to listen to our podcast, the best places to do that are on our YouTube channel at youtube.com/Gestalt IT video, as well as looking for the On-Premise IT podcast in your favorite podcast application of choice. We hope that you enjoyed listening to this. Leave us a like and a rating and a review so that everybody knows what we talk about here. Note, we're sticking to the premise. Until next time, tune in, and we can't wait to talk to you then.